In my last video tutorial, I was talking about standard access lists, and what we did was we wanted to make a standard access list to filter traffic from the 2 network right here. Okay, this is the 2 network, and we wanted to filter traffic to the 1 network over here. And so here's the access list we wrote, and it was access list 1 deny host 2.100 right here, deny host 2.101 here, and then permit any other host. So that would permit this 3rd host here because he would be part of any hosts left, right? And then we applied it to this interface right here, outbound. And that's the correct way to apply a standard access list, because if you look over here, standard access list needs to be applied if you look right here, standard access list needs to be applied closest to the destination. And if the traffic is going this way from here, following my cursor to here, then this port outbound is the closest to the destination, which would be reaching the 1 network. Then what I did was I showed how if you misapply the ACL and you put the ACL, let's say, on this router, the access list on this router, and you place it on the inbound, if you place it on the inbound interface right here on FA01, right, you're still going to block 2.100 and 2.101, but your intention was to block them from reaching the 1 network, and now you're going to be blocking them from also reaching the 4 network. So in other words, they're going to get blocked here at this router, and the unintended consequence is that both networks will be blocked, or these hosts will be blocked from reaching both networks instead of only the 1 network. And this is where extended access lists come in. Now, and so I'm going to move right now into extended access lists because this is a perfect opportunity to talk about them. Now with an extended access list, for one, you apply it closest to the source. So that would be over here where we were talking about, which was the wrong place to put a standard access list. So extended ACL is applied closest to the source. And the other thing that would have been perfect in this scenario with an extended ACL is that you can deny the source IP address plus the destination IP address. So we could have said we want to deny source 2.100 and 2.101, and we want to deny destination the 1.100 network over here. So we could have said, we're going to deny 2.100 and 2.101 from reaching the destination, the 1 network over here. So that's perfect. So we apply that ACL, let's say, on this interface, and it has the right consequence because it can block or deny or permit both the source and the destination. And optionally, we can also block a port or a service. And so that's what we're going to do right now as a way of learning about access lists. Now, to make this network go, we now have 4 networks. The 1 network, the 4 network up here. In between the 2 routers is the 3 network, and over here, this is the 2 network over here. And to do this, I just configured some static routes on these 2 routers. Router 0 has a static route to the 2 network, and R1 here has a static route to the 1 network and the 4 network. And if you wanted to see what those static routes look like, here's the commands that I put in for R0 and then 2 static routes for R1. Okay, I'll just drag that off to the side now. Alright, let's get started. Okay, so I'm going to open up R1 and we're going to write this access list. So we'll go to the command line interface. And we get to global config mode. I'm in global config mode right now. And we're going to say access dash list. And if it's an extended access list, it needs to have the number 100 to 199. So we'll start with 100. And now that's going to make an extended access list. And then the parameters are now going to be slightly different. So I'm going to drag this out over here. Let's take a look. So we'll put a question mark in. And we can see here, first of all, deny, permit, or a comment or remark. So we'll say we're going to deny, right? And we'll put another question mark. And unlike the standard access list where we could now just go straight to our IP address, the source IP address to block, in an extended access list, we can do other protocols. So you can see not just IP, which would be IP addresses, but we could do TCP, UDP, other things. So what we'll do is we're going to block though IP. So we're going to say deny IP, and we'll say now the source address 192.168.2.100, right? Then we need to put in the wildcard bits. So that's the wildcard bits for one host right there. And then we need to put in the destination address. So we'll say we want to deny them from reaching the 192.168.1.0 network, and then the wildcard bits 0.0.0.255, and we hit enter, and that's it. So now all we need to do is put in a permit statement, otherwise everything will be blocked because there's an implicit deny all or deny any at the end. So for this, for the permit, we're going to do access dash list 100, and we want to, let's say, permit everybody else. So now we have to do permit IP addresses, any source host, and then a second any to any destination. So now with a standard access list, it was just permit any. Now with an extended access list, it's permit IP, the protocol, any source, any destination. So we hit enter, and the access list is done. Now we have to apply it to the interface FA01 here, inbound. Notice extended ACL applied closest to the source. This is the source, this is the destination. So right here, inbound going into the router. Alright, so we'll say interface FA0/1 IP access group, the number of the access list, which in this case is 100, right? And then inbound. We hit enter, and now it's done. Alright, it's a done deal. Control C, show run. You can see there it is applied to the interface. Notice this is the Fast Ethernet configuration for Fast Ethernet 01. And then there's our access list. We're just denying one host. So let's give it a try. So this guy should be denied from reaching the one network. So we'll say desktop, command prompt, okay, destination host unreachable. Perfect, that's what we wanted. Notice the router that responded is 2.1. So this router right here responded, nope, can't do that. Alright, so now we'll go to the other host here. 2.101 should be allowed. So we'll go here and we'll try the same thing. And ARP broadcast is resolving the IP address to MAC addresses, and as soon as that happens it should work. So we get a timeout, but hopefully we'll start getting, there we go, there's a reply. And now if you were to do it, we've already got our ARP cache set, so it's working. Alright, so that worked out well. Okay, and then off screen what I did was I changed the access list statement here so that you can see it now reflects the current state of the access list. Notice the access list is on R1, and it's also applied on R1 on interface FA0/1. Here's the commands we put in.